a shot. All right, so I'm Joe Marini. I'm on the developer relations team here at Google. I'm going to talk about Chrome apps. So basically, every time that Christian said the word Firefox, just substitute the word Chrome. Thank you. Good night. No, I'm kidding.
You're implementing all the APIs?
That's right, everything. Why not? So actually, before I get started, that's my information, by the way. If you want to email me or bug me online, that's fine. Please feel free to reach out. So let me tell you a little story about HTML outside the browser. How many people remember Dreamweaver? A few hands go up. Okay, good. So I was one of the original Dreamweaver engineers about 18 years ago. Yeah, that's how old I am. And so back then, when we were building Dreamweaver, we got this idea. We said, back at the time, applications like Photoshop and other apps like Quark Express, they had these plugins, right? So you can get plugins from all these different, places and load them in, little pieces of functionality. And up until that point, they were all built using C++ or some other native language. And we said, let's change that. This is going to be Dreamweaver. Let's make plugins buildable out of HTML and JavaScript and CSS. So all those little things that you see in Dreamweaver, the palettes, all the little floating windows, the whole menu structure, all of that was built using web technology. And this is 18 years ago. And I thought, this is the first time I ever saw or even considered the idea of HTML being doing something useful outside of a browser environment. And I remember thinking to myself, wow, this is awesome. This is the future. This is the future today. We have actual apps, well, at the time, little mini apps, being built out of web technology. And then it went promptly nowhere, right? It never took off, it didn't go anywhere. So here we are, 18 years later, and not only do we have, Firefox OS-based HTML5 apps, we have Chrome HTML5 based apps. So I can't believe we've made this much progress. 18 years, it's finally happening. I'm feeling great about this. So it's just an awesome feeling. I thought I'd start off with a little bit of demos because demos, I think, usually do a pretty good job of explaining what it is I'm going to talk about. So what I'm going to do is just show a couple of demos. I'm going to launch some of these apps. How many people have heard of 500 Pixels? You heard of these guys? Yeah, a few of you. These guys do a professional photo discovery service, and you can see I have the app running here, and I can click on photos and cycle through them. This is all HTML5, by the way, running in a native app outside the browser, right? You see, there's no URL bar, there's no forward back buttons, right? You can see, I don't know if you can make it out, but here on the Mac, it gets its own window, its own menu bar. The title bar looks like a native one. So anyway, the idea is that they look and feel native. Here's another one. There's a magazine called The Economist. It's a UK magazine. One of the things I want to point out is that when I bring this up, you see this little text down here. It says available to read offline, right? So if I didn't have a connection, again, this is all HTML5. There's nothing native about this. It's all web technology. I can click on stories and I can just cycle through them. Pretty good performance. But again, it's all available offline. It runs outside the browser. Let's take a look at one more. Here's one. This is the Weatherbug app. This is an example of an app. They decided not to use the native windowing Chrome, right? So you can see the title bar is not there. They built their own. Here's their close box up here, their minimize box, and so on. So you have full control over how your UI looks, right? You can tell, again, it runs outside the browser, runs offline. Anyway, you get the idea. All right, let's go back to this slides. So why did we do this? So, why would you build a Chrome app? I mean, obviously the web is great, right? I mean, we're Google, we love the web, right? Web apps are fantastic. There's nothing inherently wrong with the web. There's lots of great web apps out there, and for the most part, they really rock. The problem is there comes a time when they don't rock so much, right? There comes a time when, you're either offline, or we've all seen this, right? You don't have a connection, you try to go someplace, it doesn't work. How about games? Games are great, right? Flappy Bird, Halo, there are lots of great games out there on the web. Problem is, there are times when games don't rock so hard either, right? Sometimes keyboard, mouse isn't really great, you wish you had a nice controller, right? These days you can't, it's very hard to provide a native controller experience on the web because it requires USB, it requires Bluetooth, right? There's no standard way of doing that in the web just yet. So there are times when, you want to build an application that takes advantage of the native platform, you can't do it. So why build a Chrome app? Well, Chrome apps run offline by default. One of the things that we built these things to do was work when there's no connection. And I'll talk a little bit about each of these as we go on. But the idea, basically, one of the main founding principles of these things is that when you don't have an internet connection, you can at least do something. And now, granted, some apps aren't very useful when there's no connection, right? I mean, so take Skype, for example, right? 95% of Skype's value is only there when you're online, right? But I'm offline, I should still be able to do things like manage my contacts. I should still be able to do things like see my call history. So even apps that really only work when they're online usually have some redeeming value even when they're not connected. So we designed Chrome apps to run offline by default. They also run across all the popular platforms. So I'm doing this on a Mac, but when you build a Chrome app, just by virtue of it being a Chrome app, it runs wherever Chrome runs. So that's Mac, Windows, Linux, ChromeOS, iOS, and Android. And I'll talk a little bit about mobile in a little bit. Okay, but the idea is that they run where the Chrome runtime runs. They give you access to the underlying platform and the underlying hardware. So things like the USB ports, things like Bluetooth, things like the camera, the microphone, the network, right? So things that you'd like to be able to do in an app that are very hard or impossible to do in the web today, we provide ways to do things like that. As you saw, they provide a rich, immersive UX. They run outside the browser. They run in their own window. If you like the platform's native window, Chrome, that's great. If you don't, that's great too. You can build your own. But the idea is that you can build a nice, native-looking app out of web technology that runs where Chrome runs. And then finally, there's distribution and updating. So we distribute these via the Chrome Web Store, except for mobile. On mobile, they go through whatever the native app store is. Play, Apple App Store, right? On desktop, it goes through the Chrome Web Store. So the Chrome Web Store handles things like updating, right? You publish your app up into the store. We do a whole bunch of checks to make sure that you're not trying to steal bank accounts or whatever. And then we push it out. And usually that's a very fast process. We don't do any kind of approval or anything like that. We just simply do like a malware scan, security scan. We do that in the background. And pretty much your app is available within about an hour of you publishing it. So, and revenue sharing, we only take 5%. So the Play Store takes 30%. That's a little bit of a source of tension inside Google. But 5% revenue share, you keep most of the money. All right. So let's talk a little bit about what it means to build a native Chrome app. So offline is interesting. There's actually a couple of different versions of offline. So let me talk about that first. So what does offline really mean? Well, there's true offline when you've got no connection, right? I'm in a plane, I'm in the desert, right? I'm in some secluded room in my building somewhere. There's no connection whatsoever. But most of the time, offline really means crappy offline, right? You've got a bad connection. You're in a cafe and you didn't tip the barista and now the Wi-Fi is mysteriously not working, right? Or you're in some crowded conference or whatever. You're in your childhood bedroom and the Wi-Fi doesn't quite reach that far, right? So there's different kinds of offline. Now native apps respond to this as if it didn't happen, right? When you're in Sublime Text and the network connection comes and goes, are you screwed? No, right? Because all the UI, all the UX, it's all local to the machine. It's not depending on the network to go get the next page. It's not depending on the network to get the dialogues or all of the UX that the app is made of. And so that's how Chrome apps are built as well. So all the app's resources are stored locally and your app can thus be launched at any time. You saw I went over to my dock. Oh, well, yeah, on the Mac it's a dock. On Windows, it's the start menu. On Windows 8.1, it's, I guess, the start menu because they're going to bring it back. On Linux, it's whatever Linux does, right? So, but the thing is, you can launch at any time. The user has no idea whether it's, they shouldn't have to know whether they're online or offline just to launch an app. Now, what that means, of course, is that as an app developer, you have to plan for having an offline app experience. So you have to, all your assets are going to be stored locally. Typically what you want to do is factor your app so that your UI is separate from your data layer. Your app is just talking to a data layer, which is transferring data back and forth across the network as it needs to. You don't want a situation where UI is coming down from the web because that's not very efficient. And we support all the standard stuff, right? We support things like Navigator Online. It's not perfect, but it's pretty good for at least determining whether someone ripped the Ethernet cable out of the machine or the Wi-Fi is turned on or off or not. We also have ways of storing data. There's lots of ways of storing data within Chrome apps. There's IndexedDB, there's the file system, the Html5 file system we support. We don't support certain types of web standards like Windows local storage because it's synchronous. And so we can't have the user sitting there twiddling their thumbs while megabytes of data are going from local storage. So we have the same API, but we give you an asynchronous version of it, and that's the Chrome storage API. And I'll show that in a little bit. The structure of a Chrome app, not real rocket science. You basically build it the way that you normally would. You've got your HTML, you've got your JavaScript, you've got whatever other assets that you want to put into it, images, whatever. And all we do is ask you to build a manifest file, kind of like what the Firefox OS apps do. There's a manifest file that goes along with this. And then there's a JavaScript file where you define various entry points into your app. And it's basically just a bunch of event listeners, right? Listening for getting launched, listening for getting suspended, listening for a push message coming in, things like that. So you take all of this, you package it all up, and then this is what goes up into the Chrome Web Store. It's typically just basically you package it, it's like a zip file, it gets submitted, up it goes. So just to give you an example, this is an example showing saving some data locally. I know that text is a little bit small. Can you guys more or less see it okay? It's basically, yeah, all right. So so I talked about this a little bit. So right here, this is the API for storing data. And you can see that there's a local version of this, and then there's a setter and there's a getter. So you can basically give it an object with properties of the data you want stored, and then it's asynchronous, so there's a callback function. And it works pretty much the way you'd expect it to, right? You store the data, you get it back. This is just one of the ways of storing data. It's pretty good for like small data sets, less than megabytes, like something like preferences or things like that. There's ways of storing larger data sets. So in addition to being offline by default, one of the things that we wanted to make sure that these did a really good job of was working cross-platform by default, because Chrome works cross-platform, and one of the key advantages of building web-based apps is that you get a really great cross-platform experience. So if you think about what cross-platform means, right? Like years and years ago, like back when I was working on Dreamweaver, for example, if you wanted to build a native app, essentially you would build a Windows app, right? That's basically what you did. And then to address the 10% of people that didn't have Windows, and I'm being generous when I say that, you would build a Mac app, right? This is the way things used to be a long time ago. So today, when you think about what cross-platform means, you still got Windows, right? But you've got multiple versions of Windows now. You still have the Mac. Mac is still there, but you've got multiple versions of the Mac. You've got these mobile OSs, right? You've got Linux. And usually people laugh when I say Linux, but there's tens of millions of people using Linux. Ubuntu alone has what, 20 million users? I mean, there's a lot of people out there using Linux. And of course, ChromeOS. ChromeOS is on fire right now. Now that usually gets the big laugh line, but thank you for not doing that. That's great. But yeah, no, so, I mean, if you look at this slide, I mean, just on this slide alone, there's what? There's C#, C++, right, Java, Cocoa, Objective-C, and then there's all the costs that developers usually don't think of, right? Like the cost of building installers and updaters, right? All the things that take time, right? Back when I worked at Macromedia, I got tagged as the installer guy. You don't ever want to get tagged as the installer guy. It's just, you'll never get away from it. Every question about the installer will come back to you. But building cross-platform apps, if you did it with native code, would be a big undertaking, and that's why the web is so great. So that's one of the great things about Chrome apps. But in addition to being offline and cross-platform, we wanted to make sure also that users got a great cloud-enabled experience, because that's something that people really expect today, right? Users expect that when they use an application and they've got data in their app, that their data will just be everywhere. It will be synced, right? Like today, how many people use Chrome? Not a lot of people. Okay, great. So when you sign into Chrome and you notice how your bookmarks, right? If you use it on more than one device or more than one, your bookmarks all get synced across the cloud, right? That's a great thing, right? So we give that infrastructure to you as a Chrome app developer. With just a few lines of JavaScript, you can sync your data across the cloud, across instances of your app, and it's great. So earlier when I showed you the Chrome storage local API, there's a sync version of it. So just by replacing the word local with sync, you get that synchronizing behavior. So you store data using the sync API, it just shows up across all instances of your app that happen to be running on multiple systems and OSs. So in addition to that, there's a sync file system API. And this is for storing much larger data sets. And it works just like any other file system you would expect. So if you've ever used the HTML5 file system, this is essentially the same thing. And it's currently backed by Drive, but it's open. So if anybody else wants to build a sync file system supported service, like, so for example, if Dropbox wanted to do this, they could go do it. So the idea is that you save your data into the file system using this API, and it can be very large. It can be multiple megabytes. It'll get synchronized eventually across all your apps. There's a push messaging API. So one of the great things about Chrome apps is that even though your app may not be running, the Chrome underlying runtime is running. So when your app registers an event listener that it wants to get cloud-based push messages, the Chrome runtime realizes that. And so even if your app is not running, Chrome is in the background listening. So when you send out a push message, your app will actually wake up. The runtime will wake your app up, say, hey, you got a message, here's the message, and then you can go off and do whatever you want to do. So again, it's really great way of maintaining engagement with your users. How many people love writing OAuth code? Yeah, me neither. So one of the things that we found was, writing OAuth is a big pain. So we provided an identity API to help solve this problem. Anytime you want to authenticate users, obviously there's some kind of identity mechanism has to come into play. There's actually, so we give you two of them. There's one API for authenticating against Google services, because when users sign into Chrome and they're using Chrome apps, typically all you have to do is simply ask their identity. They'll get that little box that says, hey, this app wants to do whatever, store data, whatever, right? Is it okay with you? You say okay, you get the user's token back, and then you can go and call all the Google services you want. There's also a third-party one. So if you want to authenticate against Twitter or whatever other third-party service there is out there, there's a way to do that as well. So let me give you an example. So the first example here, this shows using the synchronized file system. So the first line there is calling a function called setConflictResolutionPolicy. So you get to choose how you want to resolve things like conflicts. You can say, whoever got to write last, they're the winner. Or you can say, hey, you know what, I'll just do it manually, just tell me about the conflicts, I'll resolve them. It's up to you. The way that you get the synchronized file system is the way you get any other file system. You call this request file system API, and then you get an HTML5 file system object, which you can then go and write files to. And then in the background, the Chrome runtime will just do all the syncing for you. For identity, the top example here, the get auth token call, this is basically the one that you use for Google services. So that token that comes back, there's a little callback function, when the token comes back, that's a unique token that identifies that user in the Google services namespace. And so you can store that token, and whenever you want to do things like get permission to get their email addresses, you can use that token to request that dialog, and they can say yes or no or whatever. This one down here, launch web auth flow, that's for the third-party services. So the way that it works in the web normally, right, is when you want to authenticate against, say, like Twitter, you call the function, this little window pops up, and then you log in, and then the third-party service, there's a redirect URL, right? It goes back to this URL that you give it. Well, in an app, like this isn't the browser, so there's no like redirect notion. So what we do is we have this callback function that would take what would normally be the redirection from the third-party service. So when that function gets called, the third-party auth token is in there, you just extract it out of the response, and then you're off and running, and everything's good. All right, let's talk about the user experience a little bit. So as I showed you before, these things live outside the browser. They're not constrained by the URL bar or bookmarks or anything like that. Now, what this means, of course, is that when you're building an app, it's responsible for things now that it wasn't responsible for in the past. And users, it's funny, when a user is using an app, they have a different mental expectation of apps than they do of websites. It's just true. They expect that you'll have deeper platform integration. They expect that performance will be great. They don't have this frame of mind where they're using this thing called a browser. And so, for example, like in the browser world, the browser tells your web app, this is how big your window is, right? And your web app is like, okay, this is how big my window is. But in the Chrome app world, you get to control that stuff. You get to say, here's how big my window can be. Here's how little it can get. Little things like, when your app shuts down, you want to remember where your window was and how big it was, right? Because as a user, like think about it, if you're using Sublime Text, you get the window just where you want it, and then you close it down and you start it back up again, and it's this big again. That would drive you nuts, right? These are things that users of apps just expect. They expect little things like that to work. So we give you a full windowing API to handle stuff like this. You can create windows with or without frames to your heart's content. You can do things like figure out where they should go using the screen size to calculate initial position. We actually do that little thing I talked about earlier about remembering the window position and size. If you give your Windows IDs, the runtime just handles that for you. But anyway, it's things like that determine a nice user experience when people are using an app. As I showed earlier with the Weather app, you can determine and control whether or not the default OS title bar and window controls are used. You can use your own if you want to. If you don't want to use the ones that the system gives you, all you have to do is define like a div or whatever and put this little CSS, the WebKit app region :drag on it, and that becomes your drag region. So if you want to build your own title bar, entirely up to you. We give you a context menus API for native context menus integration. Users have this funny thing. They right-click, and they expect something to happen. And so we give you a nice, neat API for doing this. What's cool about it is that it works outside the app. So in the launcher, for example, if you use the context menu API, you can specify what happens when the user right-clicks on your application icon. So again, like richer platform integration that you wouldn't ordinarily get from a web app. There's an alarms API. There's an API for getting access to media galleries. So for example, if you want to get like photos or video or audio from the user's computer, again, all of this stuff is behind permissions, obviously, but there's APIs for doing all of this native platform integration. And we even have a URL handlers API. So for example, your application, if it has a certain URL scheme that it wants to be able to handle, so someone sends an email address, there's a URL in it, your application can register with the Chrome runtime and say, hey, when the user clicks on a URL that matches that pattern, my app actually knows how to handle that. Now, you have to own the URL for that, right? You have to use Google's Webmaster Toolkit tools to prove that you own the URL. Your app can't be like, oh yes, I handle Gmail URLs. But it's a great feature. All right. So I talked a little about this, about having access to the platform. So Chrome apps have access to the network, Bluetooth, USB. Obviously, this has privacy, security implications. These are things like this are where you really want to be clear to the user about when you're consuming resources like this. In some cases, you have no choice, right? You use the camera, the little light comes on, camera goes off, the light goes off. But in some other cases, like using disk space or Bluetooth or whatever, you want to make sure that you're clear with the user about when you're connected, when you're not connected. So, and of course, resources that are shared, you should remember to release these when you're done with them. Just be a good app citizen. Again, these are things that as a web developer in the past, you didn't really have to think too much about. But in the world of application development, right, they become paramount. So who's heard of content security policy, CSP? I know you have. Yes. Yeah, CSP is something, it's a relatively new thing. Basically, it controls certain aspects of how web applications can communicate with the outside world and certain things you can do inside an app.